So we have 3x less than 6, and we need to solve this inequality and graph the solution set, all right? So you solve it like any other equation. It's 3 times x. So to get x on its own, divide both sides by 3. And we get x less than 2. So when I divide by a positive, the inequality stays in the same direction, right? And so x less than 2, and then here's a number line. And I'll just put 0 here. And where's 2? Well, 2 is here, right? So x less than 2. Well, let's think about that. So here's the number 1, and here's the number 3. Now, is 1 less than 2? Is 3 less than 2? What are we talking? So 1 is less than 2. How about, and 3 is not, right? So that's not going to work. How about 0? Is that less than 2? Okay, so that works, right? And how about negative 1? We can include that. How about negative 10? All right, so that works as well. So here's some numbers that are less than 2. How about the number 4? How about the number 10? Okay, so that does not work, that does not work. So when we've got x less than 2, again, we're talking about our whole range of numbers, a whole bunch of numbers, not just one number. It's not just x equals 2. That would be an equality. This is an inequality, okay? So this is just one number. This is a whole bunch of numbers, right? Now, less than 2, it also includes decimals. Like, what about, 0.5? That's less than 2, right? And all the other decimals in here, right? How about, I don't know, negative 1.7? Like that's less than 2 as well, right? So there's a whole bunch of decimals going on here. Now, less than 2 doesn't mean 2. So give me a number that's less than 2, but it's almost 2. Can you think of one just for fun? 2.9 would be a bit bigger than 2, wouldn't it? But think of a number that's, right. There you go. So 1.9, that's pretty close to 2, but it's just less than 2. Good. And I think of another one. What's even closer to 2, but still less than 2? 1.5 would be halfway between 1 and 2. So 1.5 would be here. So what's a number, again, that's just really close to 2, but not exactly 2? How about 1.99? How about 1.999999999, right? So just for fun. So we get all the way up to 2, but we don't quite get there. And I like to represent that with the parenthesis because we need that for our intervals anyway, right? So parentheses mean not included. And square brackets mean included. So, and we kind of fill in this number line to represent all of the decimals and all of the numbers that are less than 2, right? And so it's the whole thing goes all the way to what's the smallest number we can think of? How about negative 1,000? Is there something smaller than that though? Lesser than negative 1,000? Yeah, you can go all the way towards negative infinity. You'll never get there because you can't get to negative infinity, but you go towards that in that direction. And so, yeah, our line looks like this. I'll just make it more clear, but you've got a parenthesis at the 2, and it goes to negative infinity. All right. And so that's the solution set graphed on a number line. Now, I'm just going to give the interval as well while we're at it. And the interval is min, comma, max. What's the minimum number in this set and what's the maximum number? Right, the minimum is negative infinity and comma, and then what's the maximum number in this set? Right, 2. Well, yeah, and of course you can think of it, it's really kind of 1.9999999, right? But it's actually Yeah, but it's 2 with a parenthesis to show that we get up to 2, but we don't quite reach it. Right? Yeah, 2 is not included. And can we ever reach negative infinity? So we need a parenthesis around the negative infinity, not a square bracket. Okay? So that's that. And just to show the difference, if it was x less than or equal to 2, that would be all the way up to 2 with a square bracket, because 2 is included this time, and then towards negative infinity. And the interval would look like this. Minimum negative infinity, maximum 2, but you would have a square bracket around the 2 and a parenthesis around negative infinity, because the 2 would be included in this case, but not in this. Okay? Because this is x is less than or equal to 2, whereas this one would be x is less than 2. Right?